This is our day 17 video. It's for Tuesday, April 21st. We're going to begin talking about probability. Probability in its basics is very, very easy. It can become extremely difficult. We're not going to make it extremely difficult, but it'll get a little challenging here and there. So the most basics of probability is we're going to write P for probability, and inside parentheses, we're going to put an event of what we want the probability of. And the probability of an event is the simple ratio of the number of favorable outcomes over the total number of outcomes. So number of total outcomes. The most basic, that's an O. The most basic games of probability, you can take a coin, flip a coin, a fair coin, and you can just say, what is the probability of heads? And the probability of heads would be written as a fraction, the ratio. The favorable outcomes, well, a coin has two sides. It's got a heads and it's got a tails. So the favorable outcomes, it can only happen once as a heads, but there are two possible flips. All right, so you can write the probability in three different ways. Leave it as a ratio in completely reduced form. We can do the division, decimals, 0.5, or we can change that into a percentage and say it is a 50% probability. 1 out of 2, 0.5% or 50%. Okay, so the next thing we're going to look at is a four-sided die. You're used to a six-sided die, but there are four-sided dies. If you don't believe me, Google it. It has numbers 1, 2, 3, and 4 on its sides. And I would like to know, what is the probability of rolling a 3? Well, obviously, 3 can come up in one way, and I have 4 possible outcomes. I said in one way and wrote 3 because that's what I wanted. So it can come up one way out of 4 total. So that would be 0.25 or 25%. And what I'd like you to do, please, is write it in all three different manners for right now for each and every problem. All right, so let's take a look. Probability of a prime number. Well, you got to remember what a prime number is. A prime number is a number that can be multiplied or divided by itself in one only. 1 by definition is not prime. 2 is the only even prime, and 3 is prime. 4 is not. So the probability would be 2 favorable outcomes out of 4 possible outcomes. We need to reduce that to 1/2. So if you left it as 2 over 4, that wouldn't be correct. I mean, it's correct, but you want to put it in simplified form. And of course, that's going to be 0.5 or 50%. Easy enough? Okay, for our next example, a lot of probability is done with a deck of cards. The only problem that I found in teaching probability is that a lot of students haven't played cards. I guess we have cell phones and computers now. We don't play with cards. So real quick, cards, first of all, there are 52 total cards in a deck of cards. They are divided into 4 suits. So 52 cards, they have 4 suits. We have diamonds. We have hearts, clubs, and spades. The hearts and diamonds are red, and the clubs and spades are black. Each suit contains an ace, a 1, 2, so forth and so on, till you get to a 9, a 10. After 10, we have what's called a jack, a queen, and a king. These last 3 cards are referred to as face cards. So each suit has a jack, king, and queen. So if I wanted to get the probability of picking a red 3, all right, the probability of a red 3. Well, let's take the easy part. On the denominator, the total outcomes. Well, there's 52 cards. If I'm picking one card at random, I have 52 possible cards that I can pick. Now, how many red 3s are there? Well, diamonds are red and hearts are red. Each one of those has a 3. So that would be 2 out of 52. Must reduce that. 1 out of 26, which would be 0.0385. Go up 4 decimal places and round properly, please. And that would be 3.85%. I'm going to leave all this up here with the cards. And that's the probability of getting the 2 of clubs. All right, well, again, the easy part. If I pick one card at random, there are 52 possible cards. How many 2 of clubs are there in the deck? Well, there's only one suit that's called clubs, and it only has 1 2. So there is 1 out of those 52 cards. That cannot be reduced. That's 0.0192 or 1.92%. I think I only need to do one more example for you and then tell you about one of the problems on your homework because it's a little tricky, but I'm going to give you a little hint and see how you do. I'll do it for you if need be. So let's see the probability of a black face card. All right, so let's do the easy part. We know that if we're picking one card at random, there are 52 possible cards that I can pick. All right, now how many black face cards are there? Well, we know that there are 3 face cards per suit. And again, the black suits, there are 2 of them, the clubs and the spades. So it's just going to be 3 times 2 or 6 out of 52 black face cards. Got to reduce that. 3 out of 26, that doesn't reduce. So that would be the final answer in that form. That would be 0.1154 or 11.54%. Okay, on your homework, number 4 is your most difficult problem. And sometimes you have to organize your information in a chart to get the number of possible outcomes. I'll just give you a little hint on this. The denominator is going to be the hard part, and you're going to be working with die, and you're going to have 2 dice, and you're going to be looking at the sum. So if I roll this die on top, I can roll a 1, a 2, a 3, ... however many sides it has. If I roll this dice over here, I can roll a 1, a 2, a 3, or however many sides it has. If I roll a 1 and a 1, its sum is 2. So you got to fill this whole chart in to see all the sums. So if I take a 3 and a 2, that would give me a sum of 5. So you got to fill that in and count up whatever you need for your total favorable outcomes. And then again, tricky, the denominator is your total possible outcomes. All right, guys, that's it. Keep the questions coming. Good luck, and I'll talk to you tomorrow.